created by MindSticks Foundation Trust. Welcome, class. Today, we're going to patiently decode our textbook mathematics into everyday reality. Our agenda covers real-world arithmetic progressions, money matters including finance problems, AP and geometry, tackling the practice set, and finally, the power of AP. Let's begin our explainer. Section 1. Real-world arithmetic progressions. Math is the hidden language of everyday life. Now, arithmetic progressions, or APs, aren't merely numbers printed on a page. They're the actual mathematical tools we use every single day. But this brings us to a really fundamental question. How exactly do we translate real-world scenarios into mathematical equations? I want you to pay close attention today to how we read a word problem, identify the sequence, and extract our variables to build these formulas. Section 2. Money matters. Finance problems involving loans, savings, and salaries. These are concepts you'll absolutely use in your adult lives. Consider this highly relatable money question. If you take a loan, but you decide to decrease your payment by a fixed amount every single month, how long will it take until you're completely debt-free? Let's examine a specific example. Take a look at Ajay Sharma's loan problem. Let's methodically break this down. Ajay borrows a total amount, which we call SN. Here, that total SN is 3,25,000 rupees. His first month's payment, our first term A, is 30,500 rupees. Now, because he decreases his payment by 1,500 rupees every month, our common difference D is negative 1,500. This is a very important detail, so don't miss that negative sign. Walk through this logical thought process with me, step by step. Step 1, as we just did, extract A, D, and S sub n from the text. Step 2, we substitute these right into the sum formula, which magically gives us a quadratic equation to solve. And step 3, we find the roots for n. You'll notice we get two answers for n, 20 and 21 point something. But students, why must we reject the fractional root? Well, because n represents the number of months. A month can't be a fraction in this context. N must always be a natural number. Therefore, we confidently conclude that Ajay takes exactly 20 months to clear his total amount. Let's look at another excellent example, Anvar's savings. This is a really beautiful two-part problem. Anvar saves 200 rupees, then 250, then 300, and so on. Here, before finding the total sum of all his savings, we first need to find when, in which specific month, he manages to save exactly 1,000 rupees. There's a crucial distinction here in mathematics. We use the TN formula, the nth term formula, to pinpoint that he saves 1,000 rupees in exactly the 17th month. Once we've established that n equals 17, we then switch to the SN formula, the sum formula, to calculate his total accumulated savings over those 17 months, which gives us 10,200 rupees. Do you see how the two formulas work together so perfectly? Now, let's observe Mrs. Shah's salary table. She starts with a yearly salary of 180,000 rupees, and her employer agrees to give her a fixed increment of 10,000 rupees every single year. This is a classic TN application. We want to know in how many years her salary reaches 250,000 rupees. By neatly plugging our values into the TN formula, we can smoothly calculate that her steady increments will lead to this exact target salary by her 8th year of employment. As you can see, arithmetic progressions make career planning very predictable. Section 3, AP in Geometry, Shapes and Sequences. Moving away from financial matters to physical spaces, notice this fascinating spiral shape formed by consecutive semicircles. The radius of each circle increases by 0.5 centimeters every time. If you calculate the circumference of each semicircle, you'll see they form a perfect arithmetic progression with a starting term of half pi and a common difference of half pi. To find the total length of the spiral made of 13 such semicircles, we simply plug these values into our SN formula. And look at what we get, 143 centimeters. I really want to emphasize this final calculated length. It brilliantly illustrates how abstract geometric formulas and algebraic progressions yield very concrete physical measurements. These are measurements you can actually verify in the real world with a measuring tape. Section 4, the practice set. Testing our AP rules. All right, students, sit up straight for a rapid-fire review. We have a wonderful variety of problems presented here from Problem Set 3. They're expertly designed to test your core understanding, everything from identifying negative common differences to solving for the sum of the first 30 natural numbers. It requires you to be very sharp. As you sit down to solve these, remind yourselves of these essential golden rules we've extracted from our practice questions. They will act as a strict but very helpful guide. Rule 1. The common difference d can indeed be negative, as we saw clearly in the loan problem. Rule 2. N, the number of terms, must always be a positive natural number. And Rule 3. Before you jump to apply any formula, always verify if the sequence is actually an AP first. For questions involving simple interest, I strongly encourage you to fill in the activity boxes methodically. When you calculate simple interest year by year, you'll see a constant amount being added each time. This perfectly reinforces how simple interest creates a flawless arithmetic progression over a long period, like 20 years. Remember, compound interest behaves differently, but simple interest is pure AP.
Section 5. The power of AP. Conclusion.
To wrap up our explainer today, I want to repeat this key logical phrase taken directly from our textbook solutions. Therefore, the payments are in AP. This is the most crucial realization you can make. Your step 1 is always identifying the mathematical pattern first. Once you logically prove a scenario is an AP, the formulas step in and do all the heavy lifting for you. I'll end today's session with this final provocative thought for you to ponder. How will you use arithmetic progressions to plan your own future savings or to confidently calculate your future career goals? Mathematics isn't just for passing classroom exams, students. It's an incredible tool for life. Thank you for joining me for this explainer. Keep practicing your sums, and I'll see you next time.